Hello everyone! This practice exercise is now concerned on the same oblique triangles given on practice exercise A of the same lesson, lesson number 3, the law of cosines. But instead of solving for the measurements of the remaining parts of the given oblique triangles, we are now to proceed in solving the area of the following oblique triangles. So we have number 1, oblique triangle ABC. We also have an oblique triangle PNM or MNP if you want to, and another oblique triangle at the bottom with X, Y, and Z as the vertices. We have two different formulas in solving the area of an oblique triangle. And each of the formula depends on the given measurements of an oblique triangle. For this given figures here, as we already know, for practice exercise A, these are all oblique triangles under the SAS situations. It's because two sides for all of this triangle are given in the included angle. For number 1, you have side BC which measures 2 and side CA which measures 5 as your sides, and the included angle, angle C, being 70 degrees. For number 2, same situation. You have side MN and NP, and then we have the included angle N as 130 degrees. In number 3, same as last time, we're able to identify that the measurement of angle Y, which is 88 degrees, is just between sides Z and X with the same measurement. So without further ado, we are going to solve for the area of these three oblique triangles using the formula for the area of the oblique triangle under SAS situation. We have here a common formula for the area of the oblique triangle. Other references call it K, or just for the similarity of reference for the name area, let's just call it area A. Is computed as 1/2 the product of the two sides. In this case, let's just use general form A and then B to be multiplied with sine of the included angle C. This is actually the general formula in solving the area of an oblique triangle under SAS situation. Notice here that the sides used were actually not in relation with the included angle here. My point of saying is this one. You would know that your formula is correct if your sides here, any of the notations for your side did not necessarily reflect their opposite angle. Because if you're going to have here sine B, then definitely this angle B is no longer an included angle of both sides. Similar to angle A, so they would not be similar. So again, your hint for your formula is this. Because this is a general formula, when you reach to number 2, you don't have A, B, or C here anymore, even in number 3. What you need to be reminded of is that the formula for the area of the oblique triangle under SAS situation is given as 1/2 the product of the sides and their included angle. And that included angle must be a letter or annotation that will obviously not related to any of the sides here. If this is AC, then definitely your angle here is B. If this is BC, your angle here must be A, and so on and so forth. Please apply whatever changes or that connection later on. Also, please do not be confused as to the label of this lesson being law of cosines and why is it that the trigonometric function used in solving the area is sine. This formula has a correct and exact derivation. I'm going to provide a separate video for that if you would like to. The point here is that even if the formula has sine trigonometric function or ratio, if you would like to, it's still under law of cosine since these triangles were actually solved earlier under law of cosines. So do not be confused with that. Even if it's under law of cosines, in this particular lesson, the formula still uses sine. Again, a derivation may be shared to you if you would like to. So let us use this to solve for the area of the three oblique triangles here. For number one, we could actually solve the area for this by substituting the value for the given measurement. Notice, and please do not forget, that the side here in this case, side BC, is directly opposite angle A. Hence, this side here can be labeled as side A. It is also true with side CA or AC, which measures 5, as this is the side directly opposite angle B. So this is the value of B. Luckily, all of our notations here fit the given formula because we already have A, B, and include angle C. But then again, as I mentioned earlier, if the situation will be different, especially for number 2 and number 3, and even if I will just interchange all the vertices here, you need to understand that the formula here refers to the given measurements of sides and the included angle. So let's continue here. A is actually 2 and then 5 is b, or b is equal to 5, to be multiplied with the sine value of 70 degrees. So of course you could do it like that, or if you don't like to, you could always divide everything by 2 later on, but I'm going to do that in this manner. So the area here is computed as 5 sine 70 degrees. To solve for this, of course, are always allowed to use calculators. But then again, the reminder is if you're going to use calculators, please try to input the value or the expression at once. Because if you are going to input sine 70 degrees first, and then probably you are going to round it off into two decimal places and use that value to be multiplied to 5 to get the area, there might be some issues as to the exact or the approximation of the value. So in this case, input this at once. I'm going to use the same calculator I've shared to you before here on the internet and input this at once. So we have here 5 times sine value of 70 degrees, and you will input here equals. You will get this result. So you have 4.6984 and so on and so forth. And as agreed in our class, we are going to round it off into two decimal places. So as you round it off, notice what will happen here. So this is actually approximately 4.70 right now. As if we are going to round this off, it's 8, so it will become 0 and 7 here. So the area is approximately 4.70. And since we are talking about area, even if it doesn't have any units, it's always important for us to declare that this is actually an area using a square of a unit. You could call it square units or units squared. We are going to use this because we are representing an area of an oblique triangle. So this is the answer for number 1 using the given formula. If ever we reach number 3 later, we have a specific unit, then you need to express as well that unit in terms of an area as you are done with your processes. So let's proceed to number 2. And number 2 still covers the SAS situation. We have this side MN, which measures 7. We have the included angle 130 degrees. And we have here this measurement as well. For another side, you have NP or PN, which measures 4 units. So instead of this formula, let's try to adopt the same concept here, as we know that 7 here is the value of the small letter p, as this is the opposite angle p, and 4 here is actually your m. So we will have here a formula which is the area equal to 1/2 the product of the sides. You have p and m, or if you don't like that, you could always use m and then p, right? Times sine of the included angle, which is angle n. Sorry for my handwriting. Let me do it again. Sine n. Then we need to substitute the values. You will have here 1/2. M is actually 4 times P, which is 7, times sine 130 degrees. To continue, you could always divide this 2 and 4, and you will get here, or you could divide rather 4 and 2, and you will get 2. And instead, you will have here the result, which is 2 times 7 is 14, times sine 130 degrees. So to get the approximated value of your area, use the same calculator I shared, or if you have your calculators as well there. So let me have this one, AC to remove all. You have A4, or A4, 1, 4, 14 rather, sine 130 degrees equals, and you will have this result rounded off into two decimal places. You will have here 10.72. You have 10.72, and declare the unit and make sure that it will cover an area. So you have here 10.72 squared units. This is now the area for the second figure here. In number 3, we may draw this one as we also tried earlier, or in the previous video rather. You could always draw this one considering that 3 and 4 are sides given and the included angle is 88 degrees. If I may, I will draw it this way. I'm just going to assume, okay, you have here angle y. So you have here angle y. And then let's say uh, z is shorter, right? So this is where z is, and this is where x is. So this is my triangle. So this is angle y, which measures 88 degrees, and this is z, the shorter one, which measures, sorry, z, which measures 3 cm. Okay, cm. All right, that. And x here is small letter x, which measures 4 cm. Okay, and then you've noticed again, and we already know that this is under SAS situation. So let's use the same formula, but we are going to adapt the formula in such a way that we are going to use the proper notations given here. This is a product of x, z, alphabetically, sine, angle, y. Okay, and then substituting all the values, you will have 1/2. X is 4. Okay, you can always write centimeter if you would like to. If you don't want, you can also just write 4 and then make use of the notation for the unit later. But since I have written this one, I'm just going to continue. Times 3 centimeters times sine y, which is 88 degrees. That would be equal to, again, we are just so lucky that a given here can be simplified further. But if in case we're in, you cannot divide this by 2, or any of the given here, probably this second side as well, just proceed. Okay, just proceed with the process. So this is actually 6 centimeters squared times sine 88. Or if you would like to, you could always write centimeters squared here later. So let me just finish this with the red color since I changed this already. Using the calculator, no need to input centimeter square, okay, because that's a unit. So that's actually 6 sine 88 equals, you will have 5.99, but luckily as we round it off, you will have here approximately, you have the area, which is approximately the answer, 6.00 centimeter squared, or square centimeter. Why do I still write 0.00 here? Because we just need to express it this manner because it's not necessarily exact. But definitely, if it's also okay if you would just like to write it by 6. Notice that there's almost no change with the value here as you multiply 6 centimeters squared to sine 88. because sine 90, which is just 2 degrees greater than this, is equal to 1. So it's almost like similar to multiplying this into 1, but not exactly 1, because then again, it's not 90 degrees anyway. So this is the final answer for number 3. This is how we solve the area of an oblique triangle using or under SAS situations. This is the formula, and then again, I could show you a proof or a derivation for that if you would like to, and if it will be available, I'm going to share it to you. And then the hint is just this is more or less pattern to the area of a triangle, which is 1/2 base times height, since you can see 1/2 here. So use this as part of your preparation in our assessment soon. Thank you very much and goodbye.